So today we'll be talking about how to sketch a cubic function. Now this is a cubic graph. Now there are a couple of terminologies you need to understand when drawing a cubic graph. Things like your X-Intercept, which is a point or points your graph cuts the X-axis. We have your Y-Intercept, also meaning it cuts the Y-axis. We also have turning point. That's where your graph goes from increasing into decreasing or vice versa. Now there are two turning points in this graph here. You have the local maximum and you also have the local minimum. Another important term you also need to know is point of inflection. Now we normally say point of inflection is where your graph goes from concave up to concave down. Now, to effectively draw a cubic function, you need to know what each and every one of these points is and how to calculate them. And that's exactly what we're going to be doing today. We'll be using this equation, which is x cubed minus 4x squared minus 11x plus 30, to illustrate how to sketch a cubic function. Now, the first step in sketching a cubic function is to determine the shape, the general shape of this graph. Now, for you to determine a general shape of the graph, you need to focus on the A. Now, if the A is positive, it looks like this, and if the A is negative, it looks like this. So it is very important that you visualize how your graph is going to look at the end of this question. If you have a positive graph, your points needs to fit into one of the diagrams of the positive graph. And the same is true for the negative graph. Now, back to the question. Since we see here that our coefficient of x cubed, which is our A, is positive, we definitely know that the graph would either look like this or it would look like this. Whatever I'm going to draw, it has to look like one of these two graphs. If it doesn't, it means I'm definitely wrong. That's step one. Now, step two is to find your Y-intercept. Now, the Y-intercept is calculated by substituting the x as 0. So we would say so with this calculation, we have our first coordinate, which is 0 and 30. Now, step 3 is to determine the x-intercept. Now, we do that by substituting y is equals to 0. Now, because this is a cubic function, the only way we can factorize this is by using the factor theorem. To understand factor theorem a little bit better, there's a link in the description with a video I did on factor theorem on how to factorize cubic polynomials. Okay, so let's get into factorizing. So using factor theorem, we factorize x cubed minus 4x squared minus 11x plus 30 to give you a linear function and a quadratic function, which is x minus 2 and x squared minus 2x minus 15. And since it's a quadratic equation, we can also factorize it again to give you x minus 5, x plus 3. And that means that this whole thing, I think I forgot to actually say that this whole thing is actually equals to 0. Right? So that's equals to 0. That's equals to 0. And that's the reason why we get our coordinates. We have 3 more coordinates, 2 and 0, 5 and 0, and negative 3 and 0. So we have our x-intercepts. Step 4 is determining the stationary points. Now, what are stationary points? Stationary points are points where a tangent to the curve is horizontal. Our turning points are stationary points. So if your graph looks like any of these two, this is our stationary points. So we say the gradient of those points is 0. If the graph looks like this, then therefore this point here, we'll consider it our stationary point. Okay, so looking at all this here, So that is your stationary points. Now, how do we find our stationary points? We normally find our stationary point by saying it is the derivative is equals to 0. The first derivative is equals to 0. So back to the question, we need to find our stationary point because it gives us our turning point. So let's try that real quick. So we would say this is the derivative of fx. Now, since we are trying to find the stationary point, which we said is the first derivative is equals to 0, we can equate both of them. These are the two x coordinates of your turning point. Now, to get the y coordinate of this turning point, now anytime you have the x coordinate of any function and you want to get the y, you normally substitute the x back into the original equation and it helps you get the y coordinate of that equation. So all we just need to do is substitute 11 over 3 and negative 1 into this original x3 minus 4x squared minus 11x plus 30, and they will give you the coordinates of our turning point are 3,67 and negative 14,81. That's one of the coordinates, and the second coordinate is negative 1 and 36. Now, the fifth step depends on how your fourth step went. Now, if you had two stationary points, like we can see over here, it means that this represents your turning point. Then you would also need to calculate your point of inflection, which is normally calculated. The second derivative is equals to 0. So meaning that we'll derive our first derivative, and the answer we get, we equate it equals to 0. It helps us find our point of inflection. Calculating this, you would get now that we've gotten the x coordinate of our point of inflection, we just need to substitute it back into the original equation to get the y, which will give you so the coordinate of our point of inflection would be 1,33 and 10,59. Now with this, we have all the coordinates we need. We have the y-intercept, we have the x-intercept, we have the turning point, and we have an extra point which represents our point of inflection. Now with this, we should be able to draw a graph. So starting with the y-intercept, then the x-intercept, then we talk about the turning points, and finally the point of inflection. Now we said before that our graph needs to look like this. Yeah, this two we see over here. So obviously it's going to look like the first one over here, and that's what we want to draw. Yeah, a weird looking N. So all you need to do is connect your point. Try to make sure it's a continuous graph as best as you can. And that's it. So as you can see, your graph is positive. We're done.